Go for it, you got it. It says, what is the area of a circle if its radius is 5 feet? Okay, let's see what we got here.
No.
Yesterday. Yesterday.
Oh no.
Yeah. Guys, when you round values, one thing I want to point out is if you're asked to round something, make sure you round it at the very end. Did you heard that? What is that? Thank you. Want to make sure. Great.
Yeah, okay. Yeah.
Mary, do you know the formula for the area of a circle?
Yeah.
What is it?
It's pi r squared.
All right, let's write that. Let's write that. Capital A for area equals pi r squared. Okay. And what is the radius of our circle? Okay. So if you were to plug in 5 into r, what would happen?
Yeah, if you turn it up, yeah.
Yeah. And would we be done? In terms of if I want the exact value, I want the exact value of this area. No, I want the exact value, which is, has to be in terms of pi. Would we be done?
78.
No, guys. No. This is something we need to clarify. We leave our value in terms of pi. That is the exact value. When you do decimal, you're already giving some rounded value because pi cannot be expressed as a decimal. They have people that have made supercomputers where they'll do pi like a billion digits or billions and billions of digits, but it would never end and there's no pattern to it. Okay? So that's why we leave it as pi. So if you just stop at area equals 25 pi, you would be done. That would be the exact value. Let's go ahead and write that. So if you plug in, like you said, it'd be 25 pi. So capital A equals 25 pi. And the units would be what units, guys? Feet squared, or square feet, because we're talking about area. Good. Go ahead, let's box that. That is the exact value of the area, is 25 pi square feet. The second part says, and give an approximate value, which is where in your calculator you punch in 25 times pi and 78.54. And that would be it.
Wait, so this is
it looks like what you started to do, where you said, okay, approximate value of pi, 3.4, times 5.
And then I squared it. Yeah.
Well, that's where we got to be careful here. Is this is pi times the square of just the radius. So let me point something out. Thank you very much. If you say, sure, if you want. Thank you. Area is not equal to this. This is something different. This is different than that. This says, let's square both parts, both factors. That's what this would become. You guys remember doing that, distributing to each factor? When you got to product each factor, the exponent gets it. So this is not the same as this. All right. So very simple formula. Keep it simple. This would be again the exact, and we have the equals, and then approximately 78. What was that figure, Jonathan? 78 and what?
78.54.
78.54. So the area is approximately 78.54. And did you use the pi key on your calculator or 3.14?
I used pi key.
Yeah, go ahead and when you do that, use the pi key. Because the pi they have programmed in the calculator is much more accurate than 3.14. And then what you do is round the variance. So here's the approximate area. So pardon me for erasing your work. But it's good. I like the practice of the arithmetic there, but we don't necessarily need to do that when it's, especially when they want the exact value. Especially when they want that just 25 pi square feet is the exact value. All right. Does anyone have any questions on the homework?
No.
Yes, Diamond?
47.
47. So let's take a look at 47. Before we do that, I want to look at 28. This was your exit ticket. Yes. No, I want you to do it in my class. You can do it after my class or after school. But could you please get your notebook out? I want you to take notes.
Hey, I have a question.
What's that? Okay. Let me get you some paper then.
If you did notes on a separate sheet of paper for the homework, do you staple that to the paper or do you just hold it?
If you do some notes on a separate
No,
sheet.
if you did your work on a separate sheet of paper from the homework, do you staple it to the homework or do you just hold it for now?
Yeah, I definitely need to. Yeah, see the hall pass. Go ahead. You definitely need to always provide the work with whatever assignment was assigned. Definitely make sure you staple the work with that. Okay. All right. So this was the exit ticket we had yesterday, and I saw where about half of you got it right. A handful of you kind of struggled with it. I saw there were different values of z being given. I also saw a lot of you were changing z to x or a or changing the letter, which is not, okay, it's a detail, but I was really interested in seeing what the value of the variable was. So if you did number 28, this is short AC because this is a 1. I can just go right to here. Only if this is a 1. I need to emphasize that because I think some of you want to go right to here when you can't, when it's not a 1. So when this A is a 1, the A coefficient is a 1, you can go right to here. And it's a simple question. Factors of 25 that add to -10. And that is -5 to -5. Some of you wrote -5 plus 5. And that would not work because this is a product of positive 25. And please check your work too. When you do these, go ahead and check. Like when you get to here, check it now. Check to see if this works out. If you FOIL this, z squared minus 5z minus 5z plus 25, fine, just keep that one first. Thank you. Thank you. It works out. Now letting each of these equal 0. Now they're both the exact same, so I can just do 1. But if they were different, let each equal 0. Solve for then solve for z. So make sure you get through all the way to here and solve for z. I think I saw at least 1 or 2 of you where you would get to here and then you'd write z equals -5. Well, z minus 5 times z minus 5 equals 0. But to find what z is, take it all the way down. set your make your equation based on what this is saying. So just be careful. I want you guys not to make these simple mistakes. So I believe, David, you had a question about, the number was, from the homework, 40 something? 47, all right. So, number 47. It says find the zeros of the function. So the zeros is where the function is 0. So that is how we're going to start this problem off.
That's what I didn't know. Yeah.
Oh, okay.
I didn't know that thing.
Do you want to still see it?
Yeah.
Okay. So you have g of x is equal to x squared plus 6x plus 8.
Did we already do this before?
I think we may have. It looks familiar.
Yeah.
We may have. But it's good. We'll go over it real quick.
I asked the question. I didn't understand. That's why I couldn't do the question. I didn't tell you more than 33.
Oh, okay, the whole section?
Yeah.
Okay, yeah, so to find the zeros, and I apologize if I didn't mention this in the last class. To find the zeros of a function, that has the same meaning as to just let the function equal 0. And that means the whole g of x part. So you would let this whole g of x equal 0. And you say, okay, 0 equals x squared plus 6x plus 8. And then they go from here. It's just like the problem in the previous part on that page. And Dorian, what would we get? Hold on, I'm asking Dorian. And let me ask you this: Can we go straight to here? I'm asking Dorian. Can we go straight to here?
Yes.
Why?
Because there's a 1.
Because this is a 1. Good. Okay. What can I fill in for here and here?
2.
No, I mean right here and right here in the front. Yeah, x and x. So let's take care of that guy. And let's go ahead and put plus plus. Even if it ends up being one of them being negative or both negative, that's fine.
2.
Maybe you use the restroom or something? Do you have a pass? Wait, hold on. So back to this. So we're saying here, plus plus, even if these are end up being negative values, that's fine to go x plus, x plus. Okay. So what are these going to be?
2.
2 and good, right? Because 2 plus 4 is 6, but 2 times 4 is 8, so it works out. So the zeros of this function is when x is equal to, and now we can say, okay, this guy could be 0, or this guy could be 0. And I think we've already done this. Subtract 2, make sure you go all the way down, x equals negative 4. So these are the zeros of the function. This is where the function equals 0, right? Because the where part, the x is the where part. That's the independent variable. What is the value of g of x? What is the value of the function when x is negative 2, when x is negative 4? And they should both produce an output of 0. So if you have time and you want to check, negative 2, 4 plus negative 12 is negative 8, negative 8 plus 8 is 0, so you know it's correct. And then here we have x equals negative 4, plug that in. 16 plus negative 24 is negative 8, negative 8 plus 8 is 0, so they both make the function equal to 0. So that's what they mean when they say find the zeros of the function. Duke. 33? All right, so we'll look at this one last one before we move on. So 33. Okay, so 33 looks like I had a little bit of work to it. Did anyone get 33?
Yeah.
Okay. What did you get for 33?
W equals 2, W equals 12.
W equals 2 and W equals 12. All right, let's see what happens here. Is it negative 12? Oh, your solutions? Okay, so Jonathan, could you mind walking me through how you did this? There's a given problem. What's the first thing you did?
I added 12. Well, I minus 12 from 16.
12W?
Yeah.
Okay, so minus 12W from each side, right? And then what would the next line look like?
So it'd be 2W squared. And it goes like, what's that, 4? Negative 4W?
Well, we have negative 16W minus 12W, so I think I remember line. Are we jumping further in the negatives, or are we jumping towards the positive? Negative 28? Yeah, careful, careful.
I don't have my work from here, it's on different paper.
Alright, it's okay. And then over here it just becomes what, negative 48?
Yeah.
And then the next step?
I just put plus 48 next to 28W on the next line.
So plus 48 on each side, okay? So we have 2W squared minus 28W plus 48 is equal to 0.
I did the tic-tac-toe.
Okay, so you could do tic-tac-toe right from here, but there is something that, if you happen to notice it, you're more than able to go ahead and factor out a 2, right? And I think that was the first thing that I mentioned, or maybe it was part of the second part, I believe. Let me see if I can find that. That's 10.3. Here, how to solve quadratic equations. Number 2, factor out GCF. This step is not necessary, but I list it because it does make it smaller values to deal with. So I want you to understand you can go straight to tic-tac-toe, no problem. There's nothing wrong with that. But I'm going to, because I can, I'm just going to factor out a 2 and make it with smaller values so you have this. And then you can just do tic-tac-toe with that. Or, do I even have to do tic-tac-toe now?
No, because it's a 1.
Yeah, it's now to 1. I can just do the simple, the short AC. So, let's see if we can do this. If we do this, we would have W and W, and then what would these be? Anthony, what would these be here?
It has to be 1.
7? But it's 7 a factor of 24? So factors of 24, there you go. Both negative because they have to make a positive as a product, but they sum to a negative, so it's a negative 12 and negative 2, and this is where it doesn't hurt to check. It doesn't hurt to go, okay, W squared minus 2W minus 12W plus 24. Just to check, okay, I did it right. You know, you hate to do all this work and then get it wrong at the very end. And then now from here, we could say that this guy could equal 0 or this guy could equal 0. 2 is just 2, it's not going to change, but definitely if this guy were 0, it would make it true. If this guy were 0, it would make it true. So W minus 12 is equal to 0, and W minus 2 is equal to 0. Adding 12 to each side, W would equal to 12. Adding to each side, W is equal to 2. When it is this simple, you can probably just see it like
Well,
that.
it's just like 1 in front of the letter when they're doing it, just change the sign.
Yeah, exactly. When it's this simple, you can just, guys, probably just see, okay, if 12, W were 12, make it 0. If W were 2, yeah, you can just, I'm fine if you guys go straight from here to here. Right here, this line here, I'm fine with that. So here are the solutions to this equation. We'll go 1235 every day. All right, so anyone need more? I'll leave this up. Thank you. Can you remind me at the end of the lesson, if we have time, I'll do it, but I want to make sure we cover enough lessons because I have to. But please let me know down at the end. So, page 100, number 35. This is the same sheet that I handed out for those of you who don't have your textbook. If you do have your textbook, page 100. All right, so on number 35, it says we have the area of a rectangle is 36, and we got side lengths of x and x plus 5. Okay, let's go ahead and label what they're talking about. So this is x plus 5, and this is x And they say that, did they give us the area? The area is 36. Right, and to be a little bit more specific, they probably could have been better and said 36 square units. So this guy has a length of x, and this side has a length of x plus 5.
I can never do it right.
Alright, just enough. You do enough of it. Alright, so this is where you guys need to write down what you know. Don't just keep it off in your head. What is the area of any rectangle? Base times height, or length times width, however you want to say it. So the area of any rectangle is just length times width, or base times height. Yep.
X times X.
Yes. What'd you get for x? You got 4? Okay. Let's see. Right, and a problem that might be this simple, you know, absolutely 4 times 9, 36, no problem. The more complicated to get, obviously, you're going to, you know. Yeah, of course, because you need building blocks. So when you let the math, eventually the problems will get more complicated. You need to have the math set up so that the math does the work for you, and you're good to go. So, area is equal to length times width. I'm just writing this down. This is the area of any rectangle, length times width. Now what I'm going to do is I'm going to fill it in. I'm going to substitute whatever value for A if I know what it is. I'm going to substitute for L, I'm going to substitute for W. Okay, so let's go ahead and do that. So what is the area? They give us the area. 36. 36 equals, do we know the length? Yeah, they give us length. This is where you got to be careful. It needs to be in parentheses, and then the width is x. Make sure that your x plus 5 is in parentheses. It would be a totally different scenario if we didn't have the parentheses around the x plus 5. So it's that whole length is that whole value x plus 5. You know, it's a lot safer to use parentheses, more parentheses than it is to use not enough. Okay, some of you might already recognize that we have a quadratic here. Right? If we expand this, we're going to have a quadratic, which is what this is about. So, Duke, what do you think we should do next? If we're trying to solve for x and work here. Well, okay, distribute the x. All right, so if we distribute the x, what will we get?
2x.
Careful. X times x. What is x times x? X squared, good. Plus 5x, good. So we have 36 equals x squared plus 5x. Okay, the next step, Macy. Yeah. Good. We're going to get this thing equal to 0. Minus 36 minus 36. 0 is equal to the right-hand side, x squared plus 5x minus 36, or you could write plus negative 36, same thing. Doesn't matter. All right, they happen to have another one where we happen to be able to use, we happen to be able to use short AC. So we can use short AC because this is a 1. And Andriana, what would this come down to? I factored this. So just going through possibilities, right? Negative 36 got a lot of factors. Got a lot of different choices. Positive 9, positive 9, and negative 4. Anyone disagree or agree with that? Agree? Okay, so could you explain how you found that?
I was dividing negative 36 by all the positive things in the bottom and just make it the positive value.
Does that make sense?
Probably.
She said she's taking negative 36, she's going through divided by 2 and 4 and 6 and seeing which pair of factors adds to 5. Right? So that's the recurring question. Factors of this guy that add to this guy. And because it's short AC, you can just go right to the linear factors. And you can always check it. x squared minus 4x plus 9x minus 36. It works out. So we're pretty much at the end here. So x plus 9, if we continue this over here, I'll work over here. X plus 9 could equal 0. Or x minus 4 could equal 0. Solving for x, subtract 9 from each side, x could equal negative 9. That's one value for x. Over here, adding 4 to each side, x could equal 4. Now, Devin, you said that you got x equals 4, right?
Yes.
Why did you say x cannot equal negative 9? Or did you get this? Oh, okay, you just went through some values of x. See what, so Devin, you just say, okay, start with 1, I'm guessing, 1, and kept doing the multiplication of, say, 6 times 1 is, okay, that's 6. 7 times 2 is 14. He kept going until he got to 4 plus 5 is 9, and 9 times 4 is 36, and okay, I'm done. And I know this problem, you could probably do it in your head. I'll definitely show your work, though, for a quiz or a test. Yes?
But if you plug in 9, it's not going to be
9 is not a solution. But if you plug in negative 9, it will work. Yep. Negative 9 times negative 4 is positive 36. So here's the thing, though. You have to remember, you have to use logic and never throw it out the window. What kind of problem are we talking about? What was this whole thing about? This whole problem?
It's probably like they probably might actually like the size of the spot like
No, this problem. What was this problem about? No, this problem. On page 100, it says the area of the rectangle is 36. Find x. And they have x as the width and x plus 5 is the length. So we're talking about a rectangle, right? Okay. Thank you. And I'm so glad that you came up with that as quickly as you did.